Okay, we're going to look at how we can use random number tables to generate samples. We're going to jump straight to the examples here. In this example, it says, here's an extract from a set of random number tables. And it says, use it to select a random sample. First one is 8 people from a group of 100 people. So we've got these random numbers here, and we want to use them to generate a sample of 8 people out of 100. So we'll just get started. So just pick the first two digits, so 6 and 8. That gives me 68. We have 7 and 2, that gives me 72. We have 5 and 3, that just gives me 5 and 3. We have 8 and 1, so that just gives me 8 and the 1, 81, and 5 and the 7, that gives me 5 and the 9, sorry, that gives me 59. So I've got 1, 2, 3, 4, 5 so far, 3 more to get. And I've got 2 and 5, 3 and 4, 7 and 0 to give me 25, 34, and 70. Okay, and that's us. So we've got 1, 2, 3, 4, 5, 6, 7, 8. We've got all our 8 numbers. We just check. So we just have a wee look and see have we any doubles, any duplicates, and we haven't. So we're good. So if you had duplicates, and you would need to mention this in your solution. If you have a duplicate, you then need to just ignore it and go on to the next one and get another one. Okay, a wee bit trickier the next one. In the first example, we didn't need to worry because our numbers were from 1 to 100. We weren't going to have anything out of our range. But in this first one, it's going to be a wee bit different. In this second one, sorry, it's going to be a wee bit different because we're going 8 people from a group of 60. So that's from 1 up to 60. So in our second example, it says 8 people from group 60. So we'll just start 6 and 8. That doesn't work for us, unfortunately. We can't do anything with that. 7 and 2, that's 72. That's not going to work for us. 5 and 3, happy days. We can use that one. 53. Next one is 8 and 1, so that doesn't work for us. Next one is 59. That works, that's fine. Next one is 25. That's going to be fine. Next one's going to be 34. That's going to be fine. Next one is going to be 7 and 0, so 70. That's not going to work. Next one is going to be 54. That's going to be fine. So we've got 1, 2, 3, 4, 5 now. Next one's 95. That's not going to work. Next one's 32, which is also going to be fine. And next one is going to be 68. That's not going to work. Next one's 74. That's not going to work. Next one's 47. And the last one is 05, which is just 5 then. So 1, 2, 3, 4, 5, 6, 7, 8, and we have our sample, and that's it. Okay, our last example is a little bit different. It says use the following extract from random number tables to select a random sample of 12 numbers, each to 2 decimal places, from the continuous range 0 is less than or equal to x is less than 10. Right, so we think about what they're actually saying here. So we want a random sample of numbers which are between 0 and 10. So if you think about just pick a random one, and it has to be the 2 decimal places, like 1.49 would be an example. Another one would be 8.75 would be an example of a number. So they're all going to have three digits in them. There's not going to be any more than 3 digits, and there doesn't have to be any less than 3 digits. So what we're going to do here is we're just going to go start at the 5 here and do 5 to 7, and that will give us our first 3 digits. The next 3 digits are going to be 4, 5, 4. That'll be my next 3 digits. 8, 0, 6. My next 3 digits. 8, 7, 2. Sorry. Then 5, 1, 9. Then 6, 0, 8. And then 0, 0, and 0. Let's just check that one. Yep, that's going to be fine because the range was 0 less than or equal to x. So you were allowed to have 0. So 0.00 is going to be fine. And then 2, 5, 2. And then 099, and then 360, and then 435, and then 742. So that will be our 12 numbers. So you can see how they've corresponded. There was our first one. That was the 527, the 454, the 806, the 872, the 519, the 608, the 000, the 252, the 099, and the 360, and the 435, and the 742. generating all of your digits. Okay, you're now ready to do the sample paper questions, which are on page 2, and they're just taken from a sample paper. Okay, the last type of sampling we're going to look at is stratified sampling, and this is used when the population is easily split into distinguishable groups. The proportion in the sample should match that of the population, so sample members are selected through random sampling. Okay, so basically this means if you imagine you had 3 year groups in a school, so say you had year 10, which had 200 people in it. You had year 11, and it had 300 people in it, and year 12, and it only had 100 people in it for some reason. So if you were, the population of this school, this particular random school has got 3 year groups, year 10, year 11, year 12, and it has 200 people year 10, 300 people year 11, 100 people in year 12. If you were doing a sample, then the fraction of the people in the sample has to be in proportion to that of the actual totals of the population. So the total population we would have here, the total would be 200 plus 300 is 500 plus 100 is going to be 600. So this would be 200 out of 600, so 2/6 we'll just do it as, 300 out of 600, so 3/6, and this would be 1/6. So whatever your sample is, whatever number of people you're going to have in your sample, you'd have to make sure the sample size 2/6 of your sample were from year 10, 3/6 of your sample from year 11, and 1/6 of your sample is from year 12, and that will be it. Okay, let's look at this example. So we'll just get rid of all of that, and then have we look at this example. This example says select a sample size of 20 from the population below. So we'll just do a wee bit of working out here at the start to see what we have in range of totals. So if you add up these things, 76, 61, 18, and 25, our total population is going to be equal to 180. So we've got 4 groups we can split into. So we've got male, and we'll say RH, that's male right-handed. So there are 76 people out of 180, and then we're going to multiply that by our sample. So the sample size is 20. So if we do that, you're going to get 8.4 recurring, and I'm just going to say take 8. So it's people we're dealing with here, so we're going to take 8 whole people. Next thing we have male left-handed. So male left-handed, we have 18 left-handed people out of 180, and we multiply that by 20, and if you do that, you're just going to get 2. So that's nice, we don't have to do any working out there at all. And then female right-handed. So female right-handed, we have got 61 out of 180, then multiply by the 20, and if you do that, you're going to get 6.7 recurring. So in that case, we'll just round up this time. We'll say take 7, and then we've got female, and what are we on? Sorry, left-handed, and female left-handed is going to be 25 out of 180, and then multiply by the 20, and if you do that, you're going to get 2.7 recurring. So for this one, we're just going to take 3. So just do a check at the end, and you can see your total, just to make sure that they should engineer the question that it would always be this, it'll always work out to the total. Sometimes in real life, if you're doing these, it wouldn't, because you are having to round up or down. Sometimes it's not going to be quite right. You just have to make an adjustment there, but once they're going to give you an exam, they should have engineered it so it will work out well. So you've got 8 plus 2 plus 7 plus 3, so 8 plus 2 is 10, 7 plus 3 is 10, 10 plus 10 is 20, so you know you've got this right. Okay, you're now ready to do exercise B, 1B, and that is on page 3.